Welcome to the wonderful world of data analysis. In this tutorial, we're going to be looking at 3 different ways of representing data using bar graphs, circle graphs, and line graphs. The first graph we're going to look at is a vertical bar graph. To do this, we're going to analyze some data from a survey taken of how 8th graders get to school. As you can see from the table, they either walk, ride the bus, take a car, or ride a bike. Looking at this data, we want a way of representing it visually. To do that, we need to know the total number of 8th graders that were surveyed, and then we can take that data and put it onto a graph showing 2 different things, one on a vertical axis and then the other variable on the horizontal axis. Notice the vertical axis is the number of students. It's properly scaled, and the horizontal axis shows the 4 different ways or means of transportation. From this graph, you can see, and it's pretty clear, to find out the total number for each one. There are 13 walkers, 25 bus riders, 21 car riders, and 4 bike riders, which you can also see from the table. Now the challenging part is to try to take this data and answer some questions about it. For instance, what percentage of 8th graders surveyed ride the bus to school? Well, looking at the data, it looks like there are 25 bus riders. To find out the percentage, you take the total number of bus riders, divide by the total, and you can find that it is approximately 37%. There are many other questions that can be answered just by looking at these 2 charts. The next example of a bar graph is a horizontal bar graph. For this activity, we are going to look at a survey about teenagers' favorite free time activity. This survey shows that these favorite activities range from video games, playing with friends, all the way down to hanging out and working on a computer. If you look at the totals, you can go ahead and create your bar graph. Notice on this bar graph, the vertical axis shows the activities chosen, and the horizontal axis shows the number of teenagers. So the bars will actually be horizontally displayed. You can also, again, find the totals, looking at where the bar ends, going down, and finding the number of teenagers who chose that activity. As you look at all the different activities, try to total up the total number of students surveyed. This is going to be important in analyzing the data. Looking at this data, it looks like there are a total of about 100 teenagers surveyed. From this, you can answer many questions. For instance, if we were to survey 1,200 teenagers and ask them what their favorite activity was, how many would likely say playing sports based on this data? To do this, you can look up at the chart or the table, find out and see that there were 24 teenagers who chose playing sports out of a total of 100, which is approximately 24%. You can use that number, 24%, and apply that to the survey that's being done here of 1,200 teenagers. If you notice, 0.24 times 1,200 will give you the total number of teenagers out of the 1,200 that would enjoy playing sports. The next type of graph we're going to look at is a circle graph. Circle graphs are usually used to represent data that can be calculated as a percent of the whole. These graphs are also sometimes referred to as a pie chart. In this example, we're going to look at data that was taken from a survey of high school students about their favorite types of sports. We're going to show it on a circle graph. Looking at the data, we have football, soccer, NASCAR, basketball, baseball. On the right side of the table, it shows the total number of students who chose that activity. If you add them up, it looks to be a total of 500. This is really important in determining how to make this circle graph. We'll start off with football. How do we determine in this circle how much of the region should be shaded for football? Well, to do this, you take the total number of students who chose football, 125, dividing by the total. When you do that, it is approximately 25%. So that means 25% of this graph is going to be football. Now, the next thing is we need to determine what the angle should be of the graph. To do that, we know that a circle has a total degrees of 360. You take the percentage, which is 0.25, multiplied by 360, which is equal to 90 degrees. That is going to give you the angle that's going to be created on that circle. And in turn, you could do this for all of the rest of the data the same exact way to find the angles and to find the percentages. After we do that, ultimately we come to creating this circle chart. As you can see from the circle chart, the region for football is 25%, and the angle created is 90%. If we were to do the same thing, for instance, for soccer, NASCAR, basketball, baseball, we would end up with a total degrees of 360 added together and a total percentage of 100%. We're going to look at another type of circle graph. This data is taken from a survey of families about their budget. There's going to be a few more pieces of data here. It ranges from all the different things that come up in making a budget. And it shows the cost on the right and the expense on the left. As you look at this data, it shows if you add them up, it's a total of $4,000 in their budget, the biggest portion being rent. We could actually create a circle graph to represent this data using all the percentages like we did in the previous graph. If you were to check this, it would look like this. Notice rent being the biggest portion, 30%, which can be calculated from $1,200 divided by the total, which is $4,000, and that would give you 30%. The next graph we're going to look at is a line graph. Line graphs are a great way to show data over the course of a time period. Here's an example of a cell phone usage over the course of a year. Looking at this graph, you notice again, the scaling is very important. On the left-hand side is minutes used, and on the horizontal axis is the month of usage. As I was saying, in this graph, you have each one plotted, and then you draw the lines between. This is a great way of showing a trend over the course of the year. And again, very important to have the scaling and label each graph. As you can see, the top of the graph is labeled, and all of the axes are labeled. You can also create these graphs from tables, just like we did from the other examples. A nice thing about the next graph, which is a double line graph, is now you can compare multiple sets of data over a time period. If we were to look at a set of data representing the salary of two people over a 5-year span, these two people, one named Carlos and one named Andrew, you can see on the left column, that is the years. On the other columns, it represents the salary earned from each person. From this data, we can sketch a double line graph, basically a line graph for each one on the same exact graph. You can try this. As you can see, it's the same exact process. You can have more time to finish it. Here's what it would look like. Notice in this graph, we have the graph labeled salaries. On the left hand side, or the vertical axis, is salary. On the horizontal axis is the year. What's really nice about this graph is there is also a key representing blue for Carlos and green for Andrew. This is a great way of analyzing the data and determining the differences and similarities between the two. As you can see from this data, Carlos' salary is always above Andrew's, and you can see how close they come at certain years. That is the last of this tutorial. Good luck on your final project. You will be creating graphs from data that you will find on the internet on a topic of your choice. Thank you.